Hello guys, and welcome to today's video. In today's class, we're going to be discussing about expansion of surds. But before I go right into the video, if this is your first time coming across my content, please I'll urge you to like the video, leave a comment below of what you think about the video, and help share the video to students, especially those who are in need of something like this. Now, let's remind ourselves of what we call expansion. Whenever you are expanding an expression, you are trying to take away the bracket. Whenever you are expanding an expression, you are trying to take away the bracket. Are you understanding what I'm saying? All right. So let's have something in this form. Let's say you are asked to expand 2 into a plus b, something in this form. Now, whenever you are expanding, it is important to know that you are to use the number or the sign or whatever closest to the bracket to expand the bracket. I will take it again. Whenever you are expanding a bracket, just know that you are to use whatever closest to the bracket, whether it's a number or a sign, whatever closest to it, or a letter. So far as that thing is close to the bracket, we are to use it to expand the bracket. So in this case, 2 is very close to the bracket, and we also know that in between the 2 and the bracket there is a multiplication sign in operation there. So what I'm going to do basically is I'm going to use the 2 to multiply each term in the bracket, right? So this 2 is going to multiply a, and this 2 is going to multiply b as well. Are you seeing that now? So I'm going to have 2 times a giving me 2a, and then 2 times b giving me 2b. Then I'm having a plus sign. Do we understand? Now let's say we have something in this form: 4a minus 2 open bracket a plus 3, something in this form. Now remember that we are to use what is close to the bracket to expand it. In this case, 4 for 4a is not close to the bracket, right? So what is close to this bracket here is minus 2, not just 2. There's a minus together with it, right? So I'm going to use the minus 2 to multiply the first term, and use the minus 2 to multiply the last term there, right? So doing that, I'm going to have 4a remains the same, minus 2 times a is minus 2a. Are you seeing that now? Then minus 2 times plus 3, of course, minus times plus will give us a minus, then 2 times 3 will give us a 6. Then you can collect your like terms by saying 4a minus 2a giving you 2a, then minus 6. Are you seeing that? Now, it's not always the case may be different. It's not always that you have a number in front here. The number could be at the back. Let's say you have something in this form: 4a plus 2 in a bracket, then you have 3. In this case now, the number is not at the front of the bracket, but it is at the back. Still know that it is the number that is close to the bracket. So I'm going to use the 3 to expand what is in the bracket. So I'm going to apply the same principle. 3 multiplies 2, and then 3 multiplies 4a. So when 3 multiplies 4a, I'm having 12a plus 3 multiplies 2 to give me 6. And this is the expanded answer, right? So having understood this, let's take a more challenging example. Let's say you have a plus b, and then a plus 2b, and you are asked to expand. Remember, when you are expanding, you are taking away the bracket, right? So in this case, we need something to be outside the bracket to be able to expand it, right? Just like this case is here. Something has to be outside for us to expand the bracket. Something has to be outside for us to use it to expand the bracket. But in this case, there is nothing outside the bracket here. Neither is there anything outside the bracket here. So how do we solve this challenging problem? What we do, is that we can either use any of the bracket to expand the other one. You understand now? We can use this bracket to expand this one, and we can also use this bracket to expand this one, however the case may be. You understand now? So how do I use this bracket now to expand this guy here? Pay attention. What you are to do is you are to pick the term one by one. I want to use this bracket to expand the second one. This is the first bracket, this is the second bracket, right? So I want to use the first bracket now, what is inside here, to expand the second one. What I'm doing basically is I will pick the first term here in the bracket, a, are you seeing that, into everything here, a plus 2b. Are you seeing that? I'm using the first term here into everything, then the second term, which is plus b, into the same thing, everything here again, a plus 2b. Are you seeing that? Now we have something outside and we have something outside. So for this bracket now, I'm using the a here to expand it, and for this bracket I'm using the b here to expand it, right? So a multiplies a and a multiplies 2b. That's what's close to this bracket. And for this bracket, what's close to it is b. So b multiplies a and b multiplies 2b. Are you seeing that? So let's expand it. So we have a times a giving us a raised to power 2, right? Plus a times 2b, that's going to be 2ab. So I'm done with this one now. So this plus here, I can drop it right here. Then b times a is not ba, of course a comes before b, so you have ab, right? Then plus times plus give us plus, then b times 2b, that gives us 2b squared, because I'm having 2 b's there. So when you're multiplying b's, you have a power of 2 on top of it. So for this expression, I'm having a squared, of course they are like terms, 2ab plus 1ab, that's a 3ab, then plus 2b squared. And of course you can't simplify anything further here because you don't have like terms, so you leave your answer in this way. Do you understand? Now, having understood this, let's work an example under Surd. Alright, let's have these examples. We are told to expand the following. Number one, we have Surd 2 into brackets Surd 3 minus 2. Let's have the solution. For question 1, we have Surd 2 into bracket Surd 3 minus 2. Now the same principle applies. We use what's close to the bracket to expand it. So Surd 2 multiplies this, Surd 2 multiplies this guy as well. So if you do that, you have Surd 2 times Surd 3. Basically you are just doing Surd 2 times Surd 3. The two numbers inside the Surd multiply themselves together, so we have Surd 6. Are you seeing that? So when you have Surd 2 multiplying Surd 3, you have Surd 6, then minus this 2 is just an integer, right? It's not having a surd attached to it, so it's going to stay outside. So you're just doing Surd 2 multiplies 2, Surd 2 multiplies 2, right? So this 2 can't multiply the one inside because it's not having a surd, right? Rather it multiplies the 1. There is a 1 outside here, so this 2 as a whole number multiplies the whole number outside the surd, while the number inside multiplies the number inside. That's why this was possible. So we have Surd 2 inside, Surd 3 inside. They were able to multiply themselves, right? But this is Surd 2, a rational number, and this is a whole number. You understand? So this whole number multiplies the whole number outside. So we're having Surd 2 multiplies 1 is going to give us 2 Surd 2, because there's a 1 here. So 2 times that 1 gives us 2, then the Surd 2. You understand? So Surd 2 multiplies 2 gives us 2 Surd 2, and we have this as the answer to that expression. Of course we can't simplify further, right? Why? Because they are unlike surds, right? For question 2, we are told to simplify Surd 3 Surd 3 into Surd 3 minus 2 Surd 5. Right? So looking at this example, the same principle applies. So 3 multiplies this, and so 3 multiplies that guy there. So we have sort 3 multiplies sort 3. Of course, both of them are sorts, right? So I'm going to have sort 9, right? Then minus sort 3 multiplies 2 sort 5. Of course, the inner numbers will multiply themselves, and the outside numbers will multiply themselves. So you know that 2 here is outside. There's a 1 outside. So I'm just saying 1 times 2 is giving me 2. Then sort 3 inside times 5 inside gives me 15. Are you seeing that now? And of course, sort 9, this is a perfect square. So square root of 9 is just 3 minus 2 sort 15. And this is the answer. Of course, you can't subtract 3 minus 2 is not possible. I believe you know why. Because this 2 is attached to the sort by multiplication sign. So it's not possible to say 3 minus 2 is 1 sort 15. This is totally wrong. You understand? So if you have something of this nature, 3 minus 2 times 5, you cannot say 3 minus 2 first, right? You have to apply body mass here, multiplying these two first. So you have 3 minus 10. You understand? So you can't possibly minus 2 from 3 because it is attached to this sort with a multiplication sign. You understand now? So we leave our answer in this form. And for question 3, we are told to expand sort 5 into sort 2 minus 4. 5 into sort 2 minus 4. 5 into sort 2 minus 4, right? Then plus 4 into sort 3 minus sort 2, plus 4 into sort 3 minus sort 2, right? So this is what we are told to expand. And expanding this, I'm going to use what's close to this bracket to expand this, and what's close to this to expand this one. So I'm using 5 here to multiply this, and 5 here to multiply this. Then I'm using 4 to multiply this one, and I'm using 4 to multiply the other guy. So 5 times sort 2, of course, is a whole number, so it multiplies the 1 outside. So 5 times 1 sort 2 is 5 sort 2. Are you seeing that? Minus is a whole number, so 4 times 5 giving us 20, right? Then we have plus 4 times 1 sort 3 giving us 4 sort 3. Then plus times minus here give us minus, right? Then we have 4 times sort 2 giving us 4 sort 2. And if you work closely, are they like terms? Of course they are like terms. This is a like term, it's having sort 2 inside. This is also a like term because it's having sort 2 inside. So if I collect my like terms, I'm having something that looks like 5 sort 2 minus 4 sort 2 plus 4 sort 3, right? I'm collecting the sorts together. Then minus 20 stayed as the end because it's a whole number. You understand? So since these are like terms, I can treat this together. So 5 minus 4 gives me 1. So I'm just having sort 2 plus 4 sort 3 minus 20. And if you look properly, of course 5 minus 4 gives me 1, right? I can't write 1 here because 1 is very minute. So I'm having 1 sort 2 plus 4 sort 3 minus 20, right? I was just checking to see if I made errors, and there are no errors. So I can't possibly simplify anything further because this is how the answer is going to be. This is a whole number. This 4 is attached to the sort by multiplication sign, and this is sort 2. So unlike, I cannot add them together, neither can I subtract 20 from it. So I'm leaving my answer in this form. Right. So for question 4, I'm told to expand 2 sort 2. Let me have that. 2 sort 2 into 5 minus 2 sort 3. 2 sort 3. So and minus 2 sort 3 minus 2 sort 3 into 4 sort 2 minus 2 sort 3. 4 sort 2. 4 sort 2 minus 2 sort 3. Let me check if I've not made a mistake. 4 sort 2 minus 2 sort 3. Alright. So this is the question we are told to expand, right? It's not difficult. So you stick to the principle. So what we said is we use the guy outside here to multiply the guy here, and use this 2 to multiply this guy. So this guy multiplies this one here, and this one multiplies the last man standing. So if you multiply, you have the whole numbers multiplies the whole numbers, and the sword multiplies the sword, right? So I'm having 2 multiplies 5 to give me 10 sword 2, right? These are attached. So 2 times 5 giving me 10. Then I repeat this sword 2 there. Then minus 2 multiplies the whole number. So 2 times 2 giving me 4. Then sword, the inner sword multiplies the inner sword. I'm having 2 times 3 giving me 6, right? Understood? All right. Then I'm having minus, I'm dropping the minus sign here. Then outside number multiplies the outside number. So 2 times 4 giving me 8. Then sword 3 times 2 giving me 6. Are you seeing that? Then of course, before you drop the sign here, the sign here will multiply the inner sign. So minus times minus giving us plus, right? Take note of that. Then 2 multiplies 2 to give me 4, right? Then sword 3 and sword 3 is 9. So I'm writing my 9 here. Are you seeing that? So from here we have that we have 10 sword 2. Of course, these are like sword because there is sword 6 here and sword 6 here as well. So they are like swords, right? So I'm having minus 4 minus 8. That's minus 12 sword 6. Then plus 4 times sword 9 is 3, right? I just put the multiplication sign in between them because this is not a sword, this is a perfect square, right? That's going to be 4 times 3. That's what I have here. And then I can't possibly subtract these because they are unlike swords. So I'm leaving this way. So I'm having 10 sword 2 minus 12 sword 6 plus 4 times 3 there is 12. And there's no possible headway here except if you want to factor out. If you want to factor out 2, of course, 2 is the HCF, right? Factoring out means I want to put a bracket there, but I'm not factoring because I'm expanding, right? So if I wanted to factor out, I will take the HCF of 10, 12, and 12, and that's just 2, right? So I factor, but since I'm expanding, I'm not factoring. So I'm leaving my answer in this form. And then for question 5, I was told to expand 5 minus 2, 5 minus 2, then I have this, then into 4 plus 2, 4 plus 2. So this is the question. Now if you notice clearly, we don't have any gateman outside the bracket. That is, there's no number standing outside, right? So we apply the principle of expansion. That is, we use one bracket to expand the other. You understand? So where this is the first bracket and this is the second bracket, since there are no numbers outside the bracket, right? And to do that, we said we pick the first number here, which is 5, then into the whole of this. So I'm having 4 plus 2, right? Then I pick the first number, then the next one is the second number, which is minus 2. I'm not picking only the 2 because the minus belongs to the 2. So I'm picking minus 2 into 4 plus 2. Are you seeing that? Alright, so to do that, we continue the normal procedure. 5 multiplies and 5 multiplies. So 2 multiplies, and of course, 2 multiplies. So 5 times 4 here giving us 20 plus 5 times 1 2. That's giving us 5 2, right? Then minus, of course, this is it here. So 1 2 times 4, that's giving us 4 2. Then minus times plus giving us minus. Then 2 times 2 giving us 4. Are you with me? So from here, I can see that I have like terms here. This is 2 and 2, so they are like terms. So I can subtract 2 of them, right? So I'm having 20 plus 5 minus 4 is just 1. So I'm having 1 2. Of course, I can't write the 1 here. Then minus 4. Of course, the perfect square. And square root of 4 is just 2. So I have like terms 20 and minus 2. They are like terms because they are whole numbers, right? So I can just say 20 minus 2, then plus 2, right? So 20 minus 2 is 18 plus 2. So this is the answer to this particular problem, right? All right. Then the last question for today, we are told to expand 3 minus 4 raised to power 2. So 3 minus 4. So 3 minus 4 raised to power 2, right? I believe we all know what this means. Whenever you are having 2 to power 2 or something to power 2, what you are asked to do is to express that number in two places. So I'm having 2 times 2, right? If you're having 3 to power 2, you have to express this number in two places, that is 3 times 3, right? Not 3 times 2. Don't make that mistake. If you're having 4 to power 2, you have to express this number in two places, that is 4 times 4, right? So having understood that, we're asked to express 3 minus 4 in two places. So we're going to have something that looks funny, but in this way, it's going to look 3 minus 4, and then again 3 minus 4. That's the meaning of the square here, right? And having understood that, we apply the same principle. There are no gate men standing here, right? So we use the first bracket to expand the other, right? So in my previous examples, I've been using the first bracket to expand the other. Now I want to use the second bracket to expand the first bracket, right? It's still the same principle. Now pay attention. The same thing you did when you were using the first bracket is what you are going to do also as you are using the second bracket, right? So I'm going to pick the first number here, which is 3, then into the whole of this. So if I'm picking from here, if I'm picking the term from here, I'm going to pick the whole of this, right? So I'm having 3 into 3 minus 4. Then I've picked this first term, so it's remaining this term now, which is a minus 4 into the whole of the first term. So 3 minus 4. Now simplifying further, we have 3 times 3 is giving us 9 minus 1 3 times minus 4, that's giving us 4 3, right? Then I'm having minus 4 times 1 3 also is 4 3. Then minus times minus is plus. 4 times 4 is 16, right? So square root of 9 here is going to be 3. Of course, I'm having like terms, so I'm having 3 3, they are like. So minus 4 minus 4, that's minus 8 3, of course, then plus 16. Then if I collect like terms, I'm having 3 plus 16 minus 8 3. Of course, the minus belongs to this guy here, right? So if you add 3 plus 16, that's going to give you 19 minus 8 3. And if you look carefully, you can't possibly subtract 8 from 19 because it's not possible, right? This is connected to the surd with a multiplication sign, right? And that's the answer to this problem. Thank you for watching, and see you on the next one.